So I'm very honored to have a speech here, to have a talk. So you may be wondering who is even this guy speaking in front of you. He's not even a prof. He's just an intern. But so I'm here to explain this. So I'm going to talk about me. So who I am, what I did, and what I'm planning for the future. So it will be through going my profile, interest, field of study, and then my ambition. So let me present myself again. So my name is Ezekiel. So the PowerPoint version is not the same. So maybe just let's skip this one. So my age is 24. So I'm Korean, South Korean, and so I came to Singapore here for study, and it's been 10 months that I've been here. But maybe one more thing that I should add on my typical biography is that I've been studying in France before coming to Singapore. So instead of coming from Korea directly, in fact, I came directly from France to Singapore and then met this organization. So as I foretold already, so I did my license degree in a French establishment, which is called Centrale Paris. So it's one of the engineering school. So for those who don't know what Grande École is in France, so we're very proud of it. It's kind of the equivalent of Ivy League, but only for engineering and business schools. So I've finished it, thankfully, hopefully last year. And through this opportunity, I had a very short period of time working with LG Innotek in South Korea. Then I'm pursuing my master's degree at Centrale Supérieure Université Paris-Saclay, and I had the occasion to become a teaching assistant in quantum physics and to work in a small enterprises named Enedis. And now, so today, I'm also doing a double degree master's degree at NUS, and also working as an intern here in Singapore at EDF Lab Singapore. So very complex education, and I hope this work experience is kind of full. So what are my interests? So I just presented who I am, so now maybe I'm going to talk what I liked and maybe justify why I'm doing what are my subject of work. So I like to hang out a little bit at night. That's a picture in Singapore at nightlife before the COVID. So I like hanging out. I like doing some music also. So this shot was also before the COVID. But talking about the COVID, maybe the most preoccupying subject that I have on my mind is the climate change. So maybe some of you have already seen this graph. So this graph is showing basically all the 4 scenarios that can happen for in the future if we do something or not in the climate change. So here you can see RCP 84.5, which means an elevation of 3 or 5 degrees, means we do nothing. We did nothing to change our customs, habit, or production of energy, and that's the worst case, basically. And RCP 2.6 is, on the other hand, the most optimistic way, and that's the Paris Agreement that we agreed on in 2015. So that's the famous agreement that Trump left, and then Biden wants to join again. So Paris Agreement, so let me give you an insight what are the goals and why it is kind of an engaging agreement. So Paris Agreement tends to aim that we divide by 3 our gas emission by 2050. So that means we will be reducing our emissions by 4% per year. So to give you an equivalent this year with the COVID, because COVID is a buzzword, thanks to the COVID, we got more clean sky, as you could see in China or everywhere in the world, and that was 4% diminution of our gas emission. So that means to achieve RCP 2.6, we have to do the equivalent of COVID until 2050. So not trying to be pessimistic here, but here that was a striking fact to me, and that is mostly that's on my core of my interest in my work and in my study. So with that in mind, let me show you why we should care about climate change. So RCP 8.5, you may remember, that's the worst case. So here on the left side of the PowerPoint, you may see a world map, and there's a zone in the equatorial zone, which is in red. So Singapore is among this region. So what does it mean to be on that region? It means that in 2050, all the year long, you won't be able to survive at the normal temperature. That means in Singapore and all the Southeast Asia countries, it means that without the air cons, you cannot survive, because humans cannot survive at this temperature. On Brazil and Amazonia, it means that the forest will be completely run out because of the temperature. And in Central Africa, well, you can imagine the demographic consequences of it. So that is quite an issue, especially in Southeast Asia. It will create a kind of a vicious circle, as in order to survive, they will have to produce more energy. And for now, the production of energy in Southeast Asia is not the cleanest in the world. And so it will, again, emit more gases, and this is quite an issue in Southeast Asia. On the right side of the slide, you may see a world map, but this is related to water availability. So this shows in the worst scenario where the water will be scarce. So surprisingly, you may see the whole European continent in orange, and that means that that is because the water may be lacking on that region for agricultural purposes. So quite an issue, not a new issue today, but so far it has been quite a big issue. So I wanted to join in the game of climate change. So what are my field of study? So with that climate change idea in mind, so I'm working in the microgrid and smart grid section with also some work in the biomass plant. So as mentioned by Prof. Chow in the lecture one, all the smart grid, all the smart campuses may be one of the components with the smart grid and microgrid. And also with all the water scarcity in mind, I'm pursuing studies on that. So my internship is more about the microgrids and biomass plants, so production of electricity, and my studies are more focused on the water. So first, let me explain what a microgrid is. So you may have heard of it, smart cities, smart campuses. What is it exactly? Why do you have to talk about it? So maybe this is a little bit too complicated, but just to put it simple, yesterday we used to produce electricity from big power plants, and it was centralized, and we distributed it to everyone. And the consumers just had to use that energy, and it was not flexible. So that model is designated as fit and forget model. So once the consumption or the production is fixed, so you fit a model, then you cannot change the consumers. So if the consumers explodes, you have to change the grid significantly. So it means more capex, infrastructure costs, and it's very not flexible. And today, what do we have? Today, we are trying to have more RE production. So it means small PV, small generators. So many more small power producers actually. So the power grid is being decentralized. And in order to manage all of it, we need smart grid. So smart grid is more the plug and play model. So many small intermittent producers can contribute to the grid. So this is the plug part. And the consumers can freely change their consumption pattern also. So here I'm going to cite a real example. So this is a Mazera program that is part of the NTU's REIT program that has been very briefly presented by Prof. Cho in the lecture one. So this is on Semakau Island. So this is a picture of an advertisement that I took on a bus station. Quite proud of it. So what they basically did was that on the Semakau Island, they have they used to treat waste there. So they need some energy, and it's on a remote area. So you see, as it is on a remote area, we
have to somehow manage to get electricity, but from where? So with Mazera, which is a microgrid, we want to demonstrate that we can produce electricity on that place locally um, from there with high penetration of renewable energy. So you can see the PV panels, so up to 50 kilowatt peak, small energy storage system, and also a genset. So microgrid doesn't mean, oh, it's PV everywhere and lithium ion battery. We also need a small generator. But the point of the microgrid is that we reduce significantly the use of the generator. Because in remote area places, on some island in Indonesia or in small villages in Myanmar, what happens is that the whole villages rely on small gensets or small carbon generating generator. And so they use it 100% of the time. So with microgrids, we want to put the PV more on the energy mix. So in this Mazera microgrid, we wanted to demonstrate that, and it was successfully awarded at ESGAN 2019 last year as an honorable mention. It also featured a V2G charging station, which means that your car can also be a mean to supply electricity to your houses or something like this. So that's where I work now. It's the ADF Lab Singapore. So my research area in my internship focuses on the biomass power plant in microgrids. So I mentioned the PV panels could be a means of our production, wind production also. But how about biomass? So this is the part I'm working on. But I'm especially working on the new smart energy management system, which is based on reinforcement deep learning, which is a part of the intelligent artificial intelligence, which is considered as real AI actually. So with this new energy management system, we tend to aim to have a real-time power management with where we can have a load flexibility, stability, and high resiliency with a plug and play of different means of production and different customers. So you may be wondering why use AI here, as we discovered by Prof. Kim. So why do we need this? We need this because where the microgrids will be are generally in the small villages, small places. But if we bring the electricity there, the economical consequences are high because they never had the electricity before, actually. So if we bring electricity, we expect the village to develop like twice the size or three times the size. So we have to adapt the need for electricity for them. So with regular programs, we cannot meet that demand for the energy with the current energy management system. So that's why the AI part come, because the AI can determine with brute changes, it can adapt quite easily and fast enough to meet that demand. So those are my research area at EDF Lab Singapore. So as I'm studying at NUS at the same time, my field of study is on the environment engineering, as I wanted to expand on my knowledge about the consequences of biomass on the environment, and also all the membrane technology for water treatment. This one, to be really honest, is I took these classes because Singapore is most known for its desalination plant and all its technology. So um, it was quite a challenge for me to study this, and I'm very enjoying it as for now. So let me talk about maybe on my ambition. So this picture is not a regular picture. You may see this picture is the one I took in the European Utility Week 2019, which happened in Paris. So I was at first really impressed that Korea has managed to be there in the European Utility Week. And so I went through the booths and tried to figure out what they were doing here. And what I found was that mostly all the Korean companies were doing and presenting was specific parts of any compounds or turbine or engines. So actually, there was no presentation of new innovative technology or digital technologies that Korea may be boast on the international stage. So um, after visiting this booth, I had this idea of maybe we should develop or maybe make more advertisement of what Korea can do on the technological side, more on the production side. So with that in mind, so I want to become in the next coming months a microgrid researcher or smart grid researcher, and maybe in the next years engineering in utilities or in environmental sector, but also an inspiring leader in a multicultural environment to make advantage of my past experiences. And finally, why not? Decades later, maybe join our space colonization program as all my work are focusing on our remote places and all about resource management. So it was an honor to talk here, and thank you very much for listening.